All right, class. So today's lesson is going to be about the line of best fit. And with line of best fit, we're going to be making predictions. So we're going to look at some key concepts. In our key concepts, we're going to be looking at how can we use the line of best fit to make predictions. And we're going to follow these steps. Step one is we're going to read the question. We got to know what we're looking for. So we're going to identify some key things that are in that question that is important. Now we're going to be using Desmos. So step two says we're going to enter our data into Desmos. And when we enter that, it all depends on what they give us. If they give us a graph, then we got to estimate the points into the T chart, then put it in Desmos. If it's already a table, that means we just got to copy the table over into Desmos. And then from that point, we go to step three. We're going to click the zoom to fit. Now, zoom to fit will put all your points in the window so that we can see them. Okay. Then after that, we're going to click add regression. Now, the add regression button is that little icon with the dots that's going to show up right beside your table. So once we click add the regression, we're going to now look at the drop down box that is attached to it. That drop down box have multiple options, but we're only going to be focusing on two of them. The two are going to be exponential and linear. Okay. Now, exponential regression is going to give us an equation that says we got y is equal to a times b raised to x. Now, this is just the intro to it. We're going to look at it a little bit more as we move through our lessons, but that's the exponential regression equation. The next one is going to be your linear regression. Your linear regression is going to be your equation y equals mx plus b. Okay. Now, that equation we've been using for a while, that's where m is slope, b is your y-intercept. Okay. Then step five, we're going to determine what values is given. Now, whether they're going to give us our X value or did they give us our Y value? Now, depending on which one they give us, that's we're going to use that to help us get our answer. Okay. And the way we enter that into Desmos is we're going to say X equals or Y equals. Okay. Then the last step, and then we're going to find the point of intersection. And when we find that point of intersection, that's going to give us our solution. And the solution is going to be two numbers, X and Y. But depending on if they gave us one of them already, the one that they did not give us is going to be the answer that we need. All right, so now let's look at our first example. Our first example says that Jamie's parents saved money for a vacation. They recorded the amount they have saved after several months in the table below. Based on the exponential best fit model for the data, approximately how much will they have saved after 13 months? So now, if we go through and we pick out our key things, first thing I will pick out is exponential best fit model. Exponential best fit model is going to give us, it's going to let us know that we need to use exponential regression. So after we enter our data, in our drop down menu, we're going to be looking for exponential regression. Now, from there, we should know that approximately means that we're going to get close to the answer that we're going to get. It's not going to be exactly, it's just going to be close to. Okay. And then the last thing it says, we need to find out how much will they have saved after 13 months. Now, if we look at 13 months, the month column is the X value. So they gave us this time our X value. So that means when we go to enter that part in the Desmos, it's going to be X equals 13. Okay. So now let's go to Desmos. We're going to start our table. So plus sign table, we got 2, 4, 7, 8, and 10. On the other side, we have 107, 135, 178, 187, and 237. All right, so once we get those typed in, we hit our zoom to fit. So this time the window was already perfect. So once we hit our zoom to fit, Now we go ahead and hit our regression button, which is the line with the dots. Now, see, we got the drop down menu that showed up. Now, the first one that's going to show is linear regression, but this one we need exponential. So we're going to hit our drop down, choose exponential regression, and you can see that the line was drawn, is drawn for us, and it's kind of curved. So exponential regressions have a curved line. Okay. Then after that, we're going to hit enter, and we're going to type in our x is equal to 13. Now, depending on where you are, you may have to zoom in, zoom out, but we're going to move it here. What we're looking for is where the two lines intersect. And the intersection is going to provide us with a solution. And that solution for this one is going to give us 13 and 312.80252. Now, the 13 is not going to be the solution. The 13 is what they gave. So the other number, which is the y value, which is 312.80, is what we can look at. Now, we said approximate, that means close to. So looking at our choices for our answers, which one is closest to 312, which will be $313. So that is the answer for our first example. Okay, so now let's look at example 2. Example 2 says Davis recorded in this table how far he can throw a ball of different weights. He modeled the data set with a linear best fit function. Approximately how far should he expect to throw a ball that weighs 12 pounds? So when we look at this problem, the first thing that stands out is that we're looking for a linear best fit function. So with the linear best fit function, we're looking to make a linear regression. So then we see approximately. Approximately means that whatever the answer we find is going to be close to the choices that they gave us. Now, the last part of it says how far can he expect to throw a ball that weighs 12 pounds? So we're looking at 12 pounds. Now, if we look at the table, pounds is going to be in the X column. So this one, they gave us our X value. So when we put it in decimals, we're going to do X equals 12. So now let's enter our table. So plus sign table, we're going to enter our values. We got 1, 3, 5, and 10. We got 74, 57, 44, and 25. Now, once we get that, we hit zoom to fit. If it's not within our window, then we hit our regression, add regression button. Now, in our drop down, linear regression is the first one. But if it wasn't, we hit the arrow, choose it, and then it will draw the line for us. Now that we have our linear regression selected, we're going to make a new line. We're going to type in x is equal to 12. Now, what we're looking for in this is we're looking for when the two lines cross. So these two lines cross here at the order pair of 12 and 11.92737. Now, if we look at that, they gave us 12. So 12 is not what we're going to be using. We're going to be using the 11.9, that decimal. So we're trying to find an answer that is close to this. So if we look at our choices, we got 6, 7, 12, and 20. So in that, the closest one to 11.9 will be answer choice C, which is 12. All right, so now let's move to example 3. It says a restaurant chain has been expanding for several years. This table shows how many restaurants the chain has since it opened in 2004. Based on the best fit linear function, in what year did the chain first include 25 restaurants? So just looking at that from the beginning, the first thing that stands out to me is best fit linear function. Best fit linear function is another one for linear regression. So we're looking for a linear regression in this. So after we know what we're looking for, it talked about the 25 restaurants. Now, 25 restaurants, we're looking for restaurants in our table. The restaurants is in the second column, which is the Y value. So they gave us our Y value in this one. So that means when we enter it in decimals, we're going to do Y equals 25. So let's go ahead and put our points in there. So plus sign, table, we got 2004, 2008, 2012, 2016, and then we got 2020. Then we got 7, 15, 22, 31, 39. Then we hit our zoom to fit to get our points in the window. Then we drop down, hit regression. Linear is the first one, so we don't have to change anything. Now we make our new line that's going to say y equals 25. So now we look for the point where they cross. They cross here at 2013.1 and 25. Now, if we look at that, the 25 was given, so that's not going to be a choice. So the other one we got is the 2013.1. So we're looking for the closest answer, and 2013 is the closest that we can get. So now let's move on to our last example, example 4. Clear everything out of Desmos, start fresh. Here it says Lawrence saves money for college. This table shows the total amount he has saved after several years. The data is modeled by an exponential best fit function. Approximately how many years will it take for Lawrence to save 1,000? Okay, so key thing that we have is exponential best fit function. That means we're looking for an exponential regression. So we got approximately again, so that means we're trying to get close to. We're going to get dead on, but we're going to be real close. And it says how many years will it take for Lawrence to save $1,000? So $1,000 we're looking at savings is money. So the money column in this one is the total amount, which is the Y. So they gave us our Y value. So what we're going to do is enter Y equals 1,000. So let's enter our table. We got 0, 2, 4, and 6. We got 500, 546.01. Got 596.26. We got 651.13. Then we hit the zoom to fit to bring it in. Hit our regression button. We're going to drop down and choose exponential. Now from there, we're going to start our new line. Our Y equals 1,000. Now in this one, it didn't just show up for us, so we got to kind of move it around to find the other line or zoom out. When we find it, get our point of intersection, get our order pair. In our order pair, we got 15.74724, comma 1,000. Now the 1,000 is what they gave us, so we're not going to look at that. Now, not the 1,000, so we're looking at the 15.74. Now we're trying to get the closest to it out of 13, 14, 16, and 20. Closest number to 15.74 is 16 years. So now that we got an understanding of how to find or make a prediction, if you have any questions, please don't hesitate to ask.